So here this is block of mass 2 kg. Let's suppose this is mass. Okay, let me take the pencil. This is block of mass 2 kg and this is 0.2 kg. Okay, here this is mu is equal to 0. There is no friction between ground and book. Okay, and this is pen, and here this friction is mu is equal to 0.3. Mu is equal to 0.3. Okay, and mu is equal to 0.3. Oh yeah, and this is 2 kg, this is 0.2 kg. Here I had applied a force of 0.1 Newton. I had applied a force of 0.1 Newton. Okay guys, so I have to find, okay, so I have to find what is the acceleration, etc., what is the friction force, everything you may possible. Okay, acceleration and acceleration of this, what is the friction force on this block. Okay, so guys, first thing to solve the question is we have to find direction of friction force. Okay, first thing we have to think about direction of friction force. Okay, first thing we have to think about direction of friction force. Okay guys, now okay, first we have to think about direction of friction. Okay, so how will determine the direction of friction force? With the help of, okay, we use concept of relative motion. First thing, relative motion. Okay, and the second thing is assume there is no friction. First we assume that there is no friction, then we use the concept of relative motion, assume there is no friction. Okay, and then third is use vector to find opposite direction. Okay, so first thing we have to do, we have to determine the direction of friction force. Okay guys, so first let's assume there is no friction. Okay, if there is no friction and I had applied a force on this 2 kg block, so let's draw the free body diagram. We had assumed that there is no friction, so by assuming this I am going to draw free body diagram. This is 2g, this is not 2g scam, and this is normal junction n1, and here this is normal junction n. Okay, who had applied this normal junction? Okay, you should know it, who had applied this normal junction. Okay, and this is force of 0.1 Newton. This is force of 0.1 Newton. Okay guys, since this 2 kg block is not moving in, there is no motion, there is no acceleration in this direction, so this should be balanced. Okay, so Fy net should be equal to 0. So Fy net should be equal to 0. This should be balanced. Okay, now there is only one force in horizontal direction, which is this 0.1 Newton. So this means that this block will move in this direction. Okay, this block will move in this direction. Now let's think about pain. This is 0.2 kg pain, this is 0.2 g, this is n. Who has applied this n? You should think about this, who has applied this n. And there is no friction force, there is no force along horizontal direction, so and so this will be in this state. Okay, so here again Fy should be equal to 0. Okay, now guys, at that instant of time. Okay, now guys, what is here, what thing you should be what is notable thing here is that this 2 kg block will move in this direction, and this will be stationary in okay, I have not written a complete spelling of stationary, just you should think about it is, it will be stationary in x direction. This means that Vx should be equal to 0. Vx is equal to 0. Now, okay, so it is, so Vx should be equal to 0, Fy is equal to, okay. So okay, so now it's time to determine what should be the relative motion of this 2 kg block. Let me write its name. Okay, block, this is pen. This, what is the relative motion of this 2 kg block with respect to pen? What is the relative motion of this 2 kg block with respect to pen? Okay, velocity of block with respect to pen. Okay, velocity of block with respect to pen, this should be equal to, okay, so I should velocity of pen minus okay, velocity of block minus velocity of pen, which is 0. So this should be equal to 2. Okay, this should be equal to 2. It will be in this direction. Okay, it will be in this direction. This means that, so what is the opposite to this? Because use the vector, if I use the concept of vector, so opposite to this will be this. Okay, opposite of this will be this. This will be the opposite. So there is, a force. So if I draw, okay, so here this is the direction of friction force. This will be the direction of friction force, because direction of friction force. Okay, direction of friction force. Okay, this will be direction of friction force. Okay, now again I should think about here. So okay guys, question is, who had applied this friction force? Okay, okay, just let's consider this question later. Okay, now we are going to determine what should be direction of friction force on point this block, on this block. Okay, so again, first step is there is no friction force, so I assuming this, I determine this this velocity, etc., whatever. Now we are going to, we are going to find out what should be direction of friction force on this pen, P. Okay, this pen P. So you know so I have to find relative velocity of this pen with respect to this block, of mass 2 kg. So velocity of pen with respect to B, this will be velocity of pen 0 minus velocity of pen is 0 minus this is the velocity of okay, oh here this should, here I write 2, sorry, forgive me, this is not 2, this is 3, whatever you want to say. Okay, so velocity of 2, 0 minus velocity of pen minus V, which is the velocity of block. Okay, velocity of, okay, this is V. So this means that velocity of pen respect to block is minus V. Minus V means this will be direction. Okay, guys, to think, you should have good knowledge about vector. Okay, yeah, this is the important. So this is the direction, direction of motion of pen with respect to book. Okay, so this is the, this will be minus V. Okay, now, so what is the opposite of it? Opposite of it will be this. Okay, this means that this is the direction of friction, direction of friction, direction of friction. Okay, this is the direction of friction, this is the direction of friction on pen. Okay, now question is, who had applied this pen? Who had applied this force? The block of mass 2 kg has applied. And who has applied this? The block of mass 1 kg. Okay, 0.1 kg. Okay guys, so these are the simple one, you should do it by yourself. Okay, now it's time to okay, okay, so we had find the direction of friction force, etc. Okay, now, so let's draw the free body diagram completely. Let's draw the free body diagram completely, because I know what is the friction force, what is the direction of friction force. So this is 0.2, so this is 0.2 g. Okay, this is the n. Who has applied this n? You should know it. And so this is the direction of friction, so this is direction of friction, F. So this is the direction of friction. Okay guys, now, And in this case the action of friction will be, okay, this is 2 kg block, so here this will be 2g, and here this is n1, and here this is n, okay, and this will be the action of friction thing, and this is f, okay, this is f, this is f, this will be also f. Think why, okay, think, think, you should think, okay. No, here this friction force and this will be same. Why? Think about it. Okay, what is the hint here? Hint is Newton third law. Newton third law. Okay, guys, you should think about Newton third law. So okay, so this both these both are the equal. Okay. Uh. Okay. So we had draw the this is the free body diagram. This is the free body. This is the free body diagram for this, and this is the free body diagram. We had draw the complete free body diagram. Okay, guys. Now we are now okay. Now let's make go to a new page. Okay. Okay. So we had draw the free body diagram. Now it's time to find out the friction force, etc. Now it's time to find out the friction force. Okay, guys, we cannot use, because here here we have to determine what should be the friction force, what should be the direction of friction force. Okay, and the friction force always hold f is always less than equal to mu m. This inequality always hold, always hold, always hold. Okay, guys, so this is the very important inequality you should think about. And here guys, here if you think about this 0.2 kg block, by thinking this equality, that f is equal to f if f applied is less than equal to mu n. We cannot determine because we do not know what is the applied force here. We do not know what is the applied force here. Okay, so by think with the help of this we cannot determine. Okay, we cannot determine because we don't know what is the force applied here. Okay, so we have to use Newton's second law. So let's write down the equation. Okay, okay, and guys, here, okay, here let's write down the equation. So in this 2 kg block, there is the only one force, this is which is F. So I should write F is equal to 0.2 A. F is equal to, let's suppose that acceleration is okay, acceleration is A. Okay, guys, the function of friction is function of friction is to oppose relative motion, to oppose relative motion. So there are two possibilities. That first is friction is able to do it. Okay, able to do it. Friction is able to oppose the relative motion. And if there is, if you think about this, if there is no relative motion, so this means that acceleration of this is 2 kg block, this is 0.2. okay, so if you think there is no relative motion, this means acceleration of A, acceleration of B minus acceleration of P, this should be equal to 0, because there is no relative motion, initially they are in rest, so this should be equal to 0. So if this should be equal to 0, so AB is equal to acceleration of P. Okay, you should think in this manner. In first look it may look strange. Okay, if you are seeing this lecture first time, it may look strange, but you have to think it in this manner. Okay, otherwise a lot of confusion will be created in your mind. So don't bother, but you have to work hard on these things. Okay, so here if acceleration of this 0.2 kg block is acceleration of this 0.2 kg block is a, so acceleration of 2 kg block will also be a. Okay, because there should be no relative motion. Let's assume there is no relative motion. So okay, so this is okay, so here this is 0.1, and again here this is the frictional force F. Okay, so this is 2. So what can I write? 0.1 minus F, this should be equal to 2a. Okay guys, so if I add both these both, what I get, 0.2 divided by 2.2 is equal to a. Okay guys, is equal to a. Okay, so what is the F here? F here is 0.1 divided by 2.2 into 0.2. Okay, and if you look at this carefully, it becomes F is equal to 0.1 divided by 11. Okay, divided by 11. Okay, so this is the friction force, and again this friction force is less than 0.6 Newton. Okay, this, because here F always less than equal to, so it is less than, so it is correct. Okay, so in simple, okay guys, if you are not going to follow, if you are not going to determine the acceleration direction of acceleration, okay, whatever concept I had tell you, then most of the time you will trouble in question like this. Okay, so the most important thing is finding direction of acceleration, direction of friction force. Okay, after that you are able to solve the question. Okay guys, so now, so it's your choice what you wanted to do. Okay, finding direction of friction force is very important. Okay guys, now, okay, thank you. So okay, thank you. So here I had draw the find, it's no, it's depend upon you. Okay, if you would try, then you can understand, you are able to solve any question of friction with the help of, first you have to think about direction of friction force. Okay, this is the very important. Okay, thank you for watching.